Let's suppose that we were interested in figuring out what the effects were on output when we have a Cobb-Douglas production function. Let's suppose our production function is k to the 0.3 times L to the 0.7, as is the case in problem 4, I believe, at the end of the chapter in MACU. And we ask, well, what happens to output, and what happens to the marginal product of labor and the marginal product of capital when the amount of labor increases by 10%. So the first thing to remember is that an increase of 10% is the same thing to multiply by 1.1. So we have labor going from L to 1.1 times L. So we're just multiplying it by a factor. That's what we mean by an increase in 10%. So let's take a look first at what happens to output. So we have our original output, we can call it y1, equal to, and you know, often in the production function, Cobb-Douglas will have the technology parameter a, so it's a times k to the 3 times L to the 0.7, and y2 is a to the k 0.3 1.1 times L to the 0.7. So now we're interested in a y2 over y1, and that gives us basically the percent change in output. In other words, how much does y2 increase compared with y1? And we can see that if we do that, we have k 0.3, 1.1, 0.7, L to the 0.7. Here I'm using my rule of exponents, where the same number raised to the power 0.7, and I should have made it clear earlier that the whole thing, 1.1 times L, is raised to the power 1.7, the power 0.7. Sorry. So we can distribute the exponent to the 1.1 and to the L, because our exponent rule x times y to the power a is the same thing as x to the a times y to the a. So that's our distribution to two different bases raised to the common exponent is the same thing as the product of each base separately times the exponent. So we distribute the 0.7 through, and then we have a to the k 0.3 times L to the 0.7, and we can see that these terms all cancel, and we're left with 1.1 to the 0.7, which is equal to 1.069. So that's about a 7% increase, right? The ratio of y2 to y1 is 1.07. So we get a 7% increase in output following a 10% increase in GDP. In the labor input into GDP. Let's continue with this problem and ask, well, what's the effect on the marginal product of capital? And you'll recall that our formula for the marginal product of capital is the real interest rate divided by the price level equals the marginal product of capital, and that's equal to alpha, in this case, times a k alpha minus 1, L1 minus alpha, where our alpha is 0.3, right, in this particular example. So the marginal product of, this is the marginal product of capital here. So the marginal product of capital then is given by this, so we can calculate MPK 1 and MPK2, and all we're doing is going to substitute in for, instead of having L here, we'll have 1.1 times L. So we have alpha a k alpha minus 1, 1.1 L, the whole thing to the 1 minus alpha sorry, that's 2, and 1 is just the same thing, alpha. So that's 1, A, K, alpha minus 1, L, 1 minus alpha. So now we can again distribute the 1 minus alpha to the 1.1 and to the L, and we'll have M, P, K, oops, sorry, MPK 2 over MPK 1 is going to be equal to, well, these are going to cancel, these are going to cancel, this is going to cancel, the L to the 1 minus alpha is going to cancel, so I'm going to have 1.1 raised to the power 1 minus alpha, which in our specific case of alpha equal to 0.3 is going to be 1.1 times raised to the power 0.7, which we've already seen is 1.069. So the marginal product of capital goes up by 7%. You have more labor, so capital is more productive. And lastly, we calculate the marginal product of labor, which is equal to the real wage, which we know is equal to 1 minus alpha times A, K, alpha, L minus alpha. So again here, we're just going to compare MPL2 with MPL1, which is what I just derived. MPL2 is going to be the same thing, but now we have labor increasing by 1.1, so that's 1.1 L, the whole thing raised to the minus alpha. Alpha is 0.3, so if we take the ratio there of the two, remember we're going to apply our rules of exponents, so we're going to get the ratio, MPL2 over MPL1. Everything's going to cancel, this is going to cancel, this cancels, this cancels, this cancels, this cancels. This cancels the L, and so we're left with 1.1 raised to the power minus alpha, which is equal to 1 over 1.1 raised to the power alpha, which is equal to 1 over 1.1 raised to the power 0.3, because that's what alpha is equal to. And you can plug that into your calculator, and you'll find that that's 0.972. So the marginal product of labor goes down by 2.8%, roughly. Right? Moving the decimal over. So that's the effects of this increase in labor on the margin, on the output, on marginal product of capital, marginal product of labor.